everyone. For the last, I don't know, maybe like week and a half, 2 weeks, we've been drawing molecules and we've been using the electron dot diagrams, which are great because they enable us to figure out what can bond, how they're going to bond, where they're going to share electrons. However, in the real world, molecules are three-dimensional. So the drawings that we've been doing have been very flat, two-dimensional drawings. They give us a great idea of what the molecules will look like, but they're not quite three-dimensional. So there is a way to figure out what the shape is going to be from the electron dot diagram, which is why we've been doing the dot diagrams the way we have. Okay, so the theory that they use to determine the shape of a molecule is the VSEPR theory. Okay, and the VSEPR theory basically stands for valence shell electron pair repulsions. Okay, if you remember when we were talking about electrons, I said that they're negative. So if I have electrons together, they're going to repel each other. So they try to get as far away from each other as possible. Because we know that, if we know where the electrons are using our electron dot diagrams, we can figure out which way the electrons are going to push the atoms in a molecule, and therefore we can figure out the shape. So let me show you what I'm talking about because it might not make sense until you see it. So I have some examples. So here we have a linear shape. Okay, so a linear shape is when you have all the molecules, all the atoms in a molecule basically form a straight line. Okay, so they're just going to be like straight line, just like you see in this image. Okay, in this case, the double bonds that we have on the carbon, this is carbon dioxide, the double bonds that we have, they're going to space out as much as they can because of the electrons, right? So remember, a double bond has 4 electrons. So you have 4 electrons on this side and 4 on this side. They're going to try to space out as much as they can. So they're going to repel each other, and the most that they can is the most that they can space each other out is 180 degrees, because once they reach 180 degrees, if they go any further, now they're closer together. So like over here, they'd be closer together. So this is as far apart as they can get. So they're going to do that. And then they're going to form a linear shape, which linear line. So most atoms that have double bonds are going to form some kind of linear shape like this. Okay. Now, in this case, we have a bent shape. Now, when I draw this, if you look at this drawing, right, for this electron dot diagram, and this drawing for this electron dot diagram, they look the same. So they both look like straight lines. However, in real life, these electrons that you see here, right, the little dots that you see on this oxygen, right, these are called lone pairs because they're not bonded, right? So they're a pair, but they're not bonded. What's going to happen with them, as you can see here, is that they are going to push, right, and repel the bonds, right, because the electrons in the bonds don't want to be near the electrons in the lone pairs. So by doing that, they're going to cause the molecule to bend. Okay, so you end up with a bent shape. Now, as you add more atoms to a molecule, the shapes get a little bit more complicated because you have more electrons, more pairs, more atoms involved. Okay. Now, if you look at this, this molecule here, this ammonia molecule, you have your nitrogen, right? You have 3 bonds, right? 3 different H's bonded on it, and then you have this one lone pair. Okay. Now that lone pair is going to repel, right? So those electrons in that pair are going to repel the electrons in the bonds that you see. So it's going to cause it, just like in the bent one, it's going to cause it to bend. But because I have those 3 atoms, it's not going to fully bend. So it comes more of like a pyramid type of thing, right? So you're going to end up with like a pyramid, and they call it a trigonal pyramidal shape because it's a pyramid, but it only has 3 sides. So as you can see, my pyramid shape has like 3 sides on the bottom. So that's why it's called trigonal pyramidal. Now, if I have 4 bonds on my center atom, okay, so in this case, my central atom is carbon, right? Because it's in the center, it's called the central atom, right? They're all going to repel each other equally. So because they repel each other equally, right? They can't, in this case, it looks flat. You can see it just looks like it's like a T. But the way, I can't even do it, the way that they're going to repel each other, they're trying to get as far apart from each other as possible, okay? And in doing so, they form this tetrahedral shape, okay? Don't worry, I'm not going to make you draw these or anything like that, but I am going to ask you to identify them. So you can identify them using your dot diagrams. And I'm going to show you how, because there is a chart available. There's actually a ton of shapes, but you're only going to be held responsible for a few of them. Okay, so there's like a ton of shapes. So if you actually looked online for molecular shapes, you'd find a whole lot of shapes. But we're going to try to keep it simple, just the basics. Okay. So here I have a link to the molecular shapes reference sheet, which I'm also going to put in Google Classroom. But here it is. Okay. So the way to read this. Okay. So number of atoms in the molecule. Okay. So that's how many atoms you have. Okay. So how many atoms in the molecule. Then the number of lone pairs are those pairs of electrons that you have by themselves. Okay. In this one, it says Na because you can't have any lone pairs on the center atom because you don't have a central atom because you only have two atoms. So if you only have two atoms, there's nothing in the middle. So you can't have a center atom. So that's what this means. So we're only asking about the electrons on the central atom, not on the ones all around it. And I'm going to show you how to read this too. So you're only held responsible for 1, 2, 3, 4, 5 different shapes. Okay. And you do have this chart that you can use. But there's a ton of shapes out there. Okay. So I'm going to show you how to read this. All right. So I put it here too so you can see it. All right. So we're going to do a little practice. Okay. So we're going to draw the dot diagram of F2, and then we're going to identify the shape. All right, so if I draw the dot diagram of F2, let me see if it'll let me do it. Okay, so I have F. Oh, no, it's not going to let me do it. All right, I did it on the next page. Okay, so I'm going to try again. All right, so if I try to draw F2, that means I have two, oops, I need a pen. That means I have two Fs, right? Each one has 7 valence electrons. All right, so we know how to do this. This is not a problem. And if you're still struggling with this, make sure you talk to me about it. Okay. So now that I drew my molecule, I'm going to use my chart. Okay. So how many atoms do I have in my molecule? I have 2 Fs. So I have 2 molecules. Okay. I don't have a center atom, so it's automatically a linear shape. So for the shape of this, I would say it is linear, right? As you can see here, right? So it is linear because I don't have a center atom, so I don't have any valence electrons on it. So it's just going to be a straight line. Okay. Now let's try pH3. So I'm going to give you a little bit of time to draw it. And then I can find my board, right? So, sorry about that. I got logged out. Okay. So I have pH3, we said. Okay. So I have 1 P and 3 H's. So I know I have 4 atoms. Okay. So if I look here, my reference sheet, I have 4 atoms, so it could either be trigonoplanar or trigonopyramidal. But I need to draw it so I can see how many lone pairs I have on my center atom. So I'm going to draw my P. Okay. My P is my center atom because we know the H's are going to go around it. P has 1, 2, 3, 4. I'm going to put this one over here, 5. Okay. And then I have 3 H's. 1 bonded here, 1 bonded here, and then I take the other one and I bond it here. Okay. So I have 4 atoms, and in the center atom, this is my center atom, I have 1 pair. We're not counting how many, we're counting how many pairs. So that means how many sets of 2 I have. So I have 1 pair, right? 1 lone pair. And when I say lone, I mean that it's not bonded. So it's a lone pair. So when I look at my chart, I have 4 atoms and I have 1 lone pair. So it's going to be trigonal pyramidal. Or pyramidal, I've heard people say. I say pyramidal. Okay, so when I draw it, right, I have 4 atoms, 1 lone pair of electrons on the center, so it's trigonal pyramidal, right? So that pair of electrons up here is going to push these away, right, and kind of make it like a pyramid shape. Okay, and then the last one I'm going to have you do, well, for today, you're going to be doing lots of these. All right, is CCl4. So if I go here, right, I have CL4. So this is not C, and then 4 I's, okay? This is 1 carbon and 4 chlorines. So that means I have 5 atoms, okay? So if I have 5 atoms, carbon always goes in the middle, I said, right? So it's got the 4, right? And then I have chlorine, 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 chlorine. 4, 5, 6, 7, bond. 1, 2, 3, 4, 5, 6, 7. Add a bond, right? 1, 2, 3, 4, 5, 6. I already did 7. 1, 2, 3, 4, 5, 6, 7. And it bonds here. Okay. So I have 5 atoms. I look at my center atom, right? This is my center atom. And I don't have any lone pairs. Okay. So I have 5 atoms, 0 lone pairs. When I look at my chart, okay, 5 atoms, 0 lone pairs, it is tetrahedral. Okay, so if I look at my shape, right, 5 atoms, no lone pairs, tetrahedral. Okay, so like I said, as long as you can draw your electron dot diagrams accurately, then you can use this chart to figure out what the shape is.